algorithms. So here we will see how we can implement in Python. Just I have taken two simple Python programs and on the same data set. So we will see how it is implemented. First of all, we will see the decision tree. Then we will see random forest. Let me just share the screen. Hope you are able to see the screen. Okay, then we will see the decision tree classification. One data set I have taken, it is the very common data set, iris data set. So it is a flower basically, where uh, this flower have three different classes. One is Setosa, one is versicolor, and another is Virginica. And in this data set, four different features are taken. One is sepal length, another is sepal width, then petal length and petal width. So based upon that, we will see how this algorithm can be implemented, and we will see what are the features and how the features are properly classified and how the features are predicted in all the data samples of this iris dataset. So in previous classes, you might have seen the Python code implementation of the machine learning algorithms. In earlier classes, maybe Devasys sir has shown you, I think. So here, just like that, we will be importing these libraries directly. First, we are importing all these libraries, this pandas, numpy, then matplotlib, then sklearn module, where it will be giving us the functions for model evaluation, including confusion matrix, accuracy, etc. Then the Seaborn library for the statistical data visualization. And directly we can import the iris dataset through this import load iris. So we have to use it in the very first beginning of the code. And decision tree we are using. So from sklearn import tree, we are just importing the tree module of sklearn, which includes the decision tree classifier class. Then you can see the iris, load iris, where the dataset will contain four features as I have already told you. And a target variable we will assign, which will be 0, 1, and 2. 0 for the Setosa, then versicolor will be 1, and 2 for the Virginica. So we have to see our data set and visualize it using binary data. Then we have to convert the data to pandas data frame so that we can do the data manipulation in an easier way. This you can read in Python about all the libraries, whatever I have used, and the data frame, about data frame. So after that, we will add a new column in C as data species iris dot target. So this new column will be added to the data frame called species, which will be the species of the iris flowers. And also this will contain the target labels, whatever I have told. After that, we are replacing the categories of the target variable with the actual name of the species. So here target equal to np.unique iris.target. Here it will extract the unique values in the target variable, means the species variable, species labels. And then target n equal to np.unique iris.target names. So this will retrieve the unique species names from the iris target names, so that we are actually finding the unique species of all the varieties. And upon that, we will be classifying how many belongs to the Setosa, how many belongs to versicolor, and how many belongs to virginica. So for that, we are using this. And then we are just replacing the data species column with the corresponding species names from the dictionary. We are putting this all into the dictionary in the target dig equal dict zip target n. So there we are creating a dictionary where the target integer labels 0, 1, 2 and the values, which are the actual species name, Setosa, versicolor and virginica. So this we are just matching those with the integer labels. Then after that we are just separating the independent and dependent variables of the dataset here. In comment I have already written, you can see. So here we are creating a new data frame X, which will contain only the feature columns, and by dropping the species column, which is the target variable. And then again we are assigning the target variable species to Y. After that, we are storing the column names features of X into names features. So we are writing it names feature X dot columns, and then the target labels into Y dot unique, which will retrieve the unique values from Y, which are the species names, 3 species names. Then we are just splitting the data into training and dataset. For this model training, we have to split our dataset into train and testing dataset. This whole dataset we are splitting into 30% and 70%, where 30% is the test size. I have written here test size equal 0.3. And we are just taking the random state, which is generally a parameter in train test split, which will control the which will be the random number generator, and it controls that so that each time we are running the same code will give us the same result after this splitting. That's why we are using it. And then you can see we are directly importing the decision tree classifier from the sklearn. And after that, we have created an instance of the decision tree classifier, which is DTC equal decision tree classifier. And here we have taken the next depth as 3. You already know that the tree has depth from the leaf node to the root node, topmost node. So here we are just taking depth 3. And these parameters can be adjusted so that you get the results in better prediction results. So this can be adjusted also. And then again, we have taken this random state as 93. Then we have fitted the training dataset to the model. Whatever this after splitting, we are just training, we're just fitting the dataset through dtc.fit xtrain and ytrain. And then we have, after all this, we are just plotting the decision tree. So based upon that features, we will be plotting the decision tree, and this result you can see. I will show you. So based upon the features and the values of the features, we can uh, show it in the visualization form, where there will be the classes and how many of the data samples are predicted and matching with the class. So that we will see through this visualization. Then after training the training dataset, we are just in the testing also we have done in ypred equal to dtc dot predict x test. So we are making the prediction on the test set x test using the train model. After all this, we are just finding the confusion matrix. Means it will show the number of correct and incorrect predictions. So graphically, we can visualize this and we can plot this, which I will show you in the later part of the code. Then we are plotting the heat map of the confusion matrix, what we have generated using Seaborn. And this will be shown in colored way. This color we have mentioned, that's why it is showing in colored way. So here you can see 2D matrix. So how many of the prediction is correctly done? So here it is showing here true levels and predicted levels you can see. So 14 numbers of the samples have been correctly predicted as Setosa. So here it is coming under Setosa and Setosa. Then for versicolor and versicolor, the true levels and predicted levels is also 14. But one was predicted wrongly here. So here it is showing versicolor predicted values with Virginica as 1. So it is not correctly matching, and also versicolor and Virginica here it is also not predicting, it is coming as 2. And then finally Virginica and Virginica is predicted for the sample of for the 14 number of samples. As you can see here we have plotted. So first 4 features we have taken. So here in the petal length, if it is less than equal to 2.6 centimeters, then we are calculating the Gini index. So I will just tell you in a brief what is it. So it is basically a measure of how the mixed classes are at a particular node. So if the Gini is 0, then the sample what we have taken at a particular node belong to the same class. So it is correctly predicted. If it is coming more than this value, then it will show that the classes are mixed. So here calculation is done, Gini calculation. So that formula is there. So based upon that, it will calculate. So in this decision tree only, it is calculating for this, or the 3 classes. And every time if it is coming as Gini as 0, so there it is completing the prediction for all the samples. And if it is coming greater values, then again it will be calculated and it will come as again 0. So finally it will be completed for all the features. So this you just see the code. We will after that we will see random forest for the same dataset. Any doubt you want to ask?
Sir,
Yeah,
so this whole script is written in Python, no, sir?
yeah, it's written in Python.
This Irish dataset is a access to a library from where
Hmm.
all this information will be stored,
So
right, sir?
here it is just we have imported from this. You can see from sklearn. So there the data set is there. So we are just importing it by this.
As you taught the reinforcement learning last class,
Mm.
so this all scripts are presenting this reinforcement learning also supervised.
I'm not getting your voice clearly.
Hello?
Can you repeat? Can you repeat?
Hello, am I audible?
Yeah, yeah, you are audible now. You can tell.
Yes, sir. So last class you taught about this reinforcement learning, na?
Yeah.
So this today you presenting this whole data set, this the Irish data set, na?
Mm.
So is this representing this reinforcement learning or the other two supervised or unsupervised?
No, it is decision tree and it is coming under supervised learning. In the rainforest, I have just shown you about the algorithms, how, what are they and how they actually work. So this is different. This is only decision tree I'm showing.
So in supervised learning, this will come this decision tree, right? So in
Yeah, yeah.
case of the unsupervised learning,
Hmm.
this whole scripts will be different, right?
Scripts will be somewhat different that I will show you.
Okay, sir.
Yeah, when we will, when I will show the unsupervised learning, then you can see. First, you just see this, then we will move. After we move on to that, I will show you. So
Yes, sir.
basically, it
And
is depending upon the data only. So here we have
okay.
the data already labeled. So that's what the difference is, supervised and unsupervised. So here every information we have the features, what are the different features. Then we are just labeling all those features and the variety of this data set. So different varieties we are taking means species of the flower. So completely it is labeled data.
So in case of reinforcement, we don't have label data, na, sir?
Yeah, that can be unlabeled.
Unlabeled. But it will be reward. It will give a reward, like a feedback.
Yeah, yeah, it's kind of feedback and it will learn based upon the environment. Means I have already shown you that one particular, suppose we have a robot, so how it will learn, how it can walk or how it can move its arm. So based upon the environment, it will automatically learn. So that thing is also somewhat advanced thing. Here we are implementing in data only. So that will be somewhat that also we have to feed some data. So their data is somewhat different. So that has some varieties of data.
Okay, sir. Okay.
Yeah,
Thank you, sir.
yeah. Basically, here also we are implementing this algorithm for classification only, uh, which is our supervised data. So we are working on mainly this data. Uh, I will show you the unsupervised algorithms in the later classes.
Okay, sir.
Yeah.
And sir, please, when you show this unsupervised, please give a comparison between these two in scripts also.
Okay, I will show you then.
Okay, sir.
Next, we will see the random forest. So it also uses this decision tree. Basically, it's an ensemble learning method. So here it will use multiple decision trees. In the decision tree, only one tree we have seen it was implementing. So here multiple trees are implemented, and the combination of all the trees, so the best one will be chosen and it will be given to us as the prediction output. So here it's the difference in the random forest. That's why it's called the random forest of the trees. So from name itself, you can uh, remember it. Here also similarly we are implementing in the same data set, and just to see how random forest classifier is imported from the scikit-learn module. Then, actually, I want to tell that with practice, you can know actually how you have to write the code, and also the codes are actually given in the internet, how we can write, how we can do the training, how we can do the testing. So based upon the data, we can write use that particular piece of code and we can implement. Here also we are doing like that only. So maybe the data set may be different, but the implementation is same. So we are just doing the same visualization here also. So here just I have loaded and I have just printed this, whatever the target names and the features name we are using. So directly we can write this and it will just print it. So after that we are training. So this kind of code is similar. We can use for different types of algorithms. Whatever you may have the data set, you can implement. If you are having the Excel file, then you can use the Excel import. Then if you are having any data in the text, that then you can use .text, so that you can directly find everywhere. If you are searching, and then you will definitely know. In this training also, we are just using the estimators, and this are random state. So random state earlier we have already used. So and estimators will be the number of trees in the forest. So this can be more than that also, but it will take more computation time for more number of trees. So this can also be done by code, that if we want to get the best numbers of n estimators and random state, that also we can generate before before using this code. When that code gives us the best values of these uh, parameters, we say these things as parameters and estimators random state. So the best value we can directly put here. Then we can train. So that also we do. That you can search it as hyperparameter tuning. So for every algorithm, the parameters are different. So the range is also different for that. You can search hyperparameter tuning. So you can get the steps of hyperparameter tuning. So various types of hyperparameter tuning are there also. One is Optuna, then Crete, then different types of parameter tuning are there. So here we have just to show you with a simple data set, we have taken these parameters directly. But for very extensive model training, so then you have to use the hyperparameter tuning so that you can get the best prediction result. Here we are getting 100% result because the data set is very simple, but we don't take simple data sets in our work. We will take thousands and sometimes in lakhs of data, and those data will be very complicated data, and they may be in different forms. So for that, we have to use the best parameter values, which will give us the best prediction of the testing and training data. So it basically depends upon this code also, and you can optimize these codes based upon whatever the values you have taken. I have used here ypred xtest, so this will slightly change, but overall the code remains the same. And this we are just in like the previous decision tree example, we are just putting this confusion matrix. So in this matrix you can see 19, 13 and 13 samples have been predicted, and misclassification is not there here. So only these three boxes you can see. So these are the samples after the test data we have taken. So out of 150, which is our ARIES data set, so 30% we have used. So 30% of that will be around what? Around 45. So 45 samples have been uh, predicted, and here we can see those. And then we are just classifying. This scores we actually see whenever we do the prediction, mainly this confusion matrix, then the uh, classification scores, what you can see here. Precision, then recall, F1 score. This you can just study what are those. So then you can know that what are these values, what are the true positive why we are using is. So basically the precision is the true positive prediction to the total number of predicted positives. Means the proportion of the predicted instance of the class are actually correct. And recall is the ratio of true positive predictions to the total number of actual positives. So suppose one feature we are having of the variety, it's not a feature, actually we are having the variety, uh, what it was, Setosa or Setosa. So if here the Setosa is already in the testing data set we are having, and it is truly matching, so then we can say that the true positive predictions we are getting with the actual positive. Then the F1 score is the harmonic mean of the precision and the recall, which will provide the balanced measure. And the support is the number of true instances for each class in the data set. Means how many samples of each class are there in the test set. So 19, 13, 13 are there. So here in the confusion matrix, you can see this classified like that. And total it was 45. So this is what we are getting. And the accuracy, the correct prediction it is taking it. And it is showing 1 because every sample is correctly classified. But in real data set, we don't get actually this 1. We will get around 0.8 0.9, 0.7 like that we will get. And the training and testing prediction also we will not get 100%. It will only be seen after we have run our model for a particular data set. Then only you can know. But these algorithms are fixed for all the data sets available out there. So if you want to classify, suppose we have another data set, like one data set we are having as uh, some drug compounds. So these drug compounds are used for treating a particular disease. We are just using that data set and we are splitting training and test data set. Then we will match all these scores, whatever I have shown in this example, we will see, and we will see the training and the testing prediction, how much they are coming closer. If it is not very close, suppose training we are getting around 90%, and for testing dataset we are getting as 50%, then we can say the model is not performing well for that dataset. So these kind of things we see in AIML for the number of datasets available. And this ROC curve you can see for this sample, whatever we have calculated. So this you can see here. So for class Setosa, for the versicolor and virginica, it is coming around 1. As I've already told you that it is predicted 100%. So it will come like that only in straight line. You can see it's green line. So all are coming together. But in real data set, it will not come like this. It will go up and down. It will go up towards the above the blue line, and it might go down the blue line. So that we have to see. And thus finally we are visualizing the feature importance, whatever the features we have taken. So petal width, petal length, sepal length, and sepal width. So the most important feature from this was coming as petal width. So it is having more value over here from 0 to 0.4. So total it will be 1.0. So out of that it is crossing 0.4. So it is the most important feature. So likewise it is going down towards the last of the graph. So till now, any doubt you having? I will share all these codes, and also you just have to see all the codes, how we can apply. Then you can definitely know. So the main codes are like that only for the classification. Any dataset you take. First, you just start with one algorithm, then you just check how this algorithm is imported in the Python. Then you just see how the data load can be done, then how X and Y is taken for the training, and then after how we can take for the testing. So like that, one by one piece of code, if you see, then it will be easier for you. And also it is not very much hard. You can directly get the codes for all this. So overall code remains the same for every dataset. Once you just see, then you will get the idea. You can try with any number of dataset. From Kaggle, you can download the dataset for practice. We don't use Kaggle. We get the actual dataset where the databases are there in the internet. So from there we take, or otherwise we are doing lab work here. So in lab also huge number of data is generated, and here various divisions are doing experiments. So based upon that also data we get and we use those data. So like that we can apply AIML in any kind of data set in real world. Okay, then you just try to practice this code, and also you just see the codes in the internet one by one, how training is done, how testing is done. So you will definitely get everything. And if you are having any doubt, you can just put in the group also. So I have to conclude the class here only, as we are having some internet issues. The work is going on here. Okay, then for today we are concluding here. We will see another algorithms in upcoming classes. And if you are having any doubt, you can post directly in the group, and you just see these algorithms and how they are implemented, and how we can use other data sets also for these predictions. Okay, then we are concluding here.